Great. Let's start with your long answer questions from Module 2, Time Value of Money, in your Financial Management subject. I'll explain everything step by step with full emojis, simple examples, and real-life use in banking or SBI PO level interviews. Hash 2.3.2, long answer type questions, detailed explanation. Let's begin with question 1 first. Ascribe effective rate of interest and nominal rate of interest with examples. What does this heading mean? This question wants us to understand two types of interest rates. Nominal rate equals basic interest rate mentioned per year. Effective rate equals the actual rate you earn or pay after compounding. Let's now understand each one in detail. A. Nominal rate of interest. Definition: nominal interest rate is the stated rate per annum per year, not including the effect of compounding. Formula: just the basic rate, e.g., 12% per annum. Example: bank says 12% interest per year compounded quarterly. Here, 12% is the nominal rate. B. Effective rate of interest. Definition: effective interest rate is the real rate you earn or pay after including the effect of compounding during the year. Formula: text effective rate arc left 1 plus frac in right quid n minus 1, where I equals nominal annual rate in decimal, nt equals number of times compounding happens in a year. Shed C. Let's understand with an example. You invest $1,000 at 12% nominal rate compounded quarterly. So nominal rate I equals 12% or 0.12, n equals 4 quarterly. Effective rate left 1 frac 0.1244 right squared. 4 minus 1 equals 1.03. 4 minus 1 equals 1.1255 minus 1 equals 0.1255. So effective rate 0.55% is 12.55%. D. Key points to remember. Nominal rate is only the mentioned yearly rate. Effective rate shows the real gain or cost after compounding. More frequent compounding is higher effective rate. Used in bank loans, savings, credit cards, etc. E. Real life and bank PO interview link. As a future probationary officer or manager, you'll deal with explaining interest to customers, selling investment or loan products, comparing bank schemes with effective rates, interview questions like, what's the difference between nominal and effective interest? Must know. F. Summary, nominal versus effective rate table. Concept, nominal rate, effective rate. What it shows, just stated rate. Actual earning interest, includes compounding? No. Useful for, loan documents. Comparing actual cost increases with compounding? No. Yes. Short motivation to keep going. You're not just studying formulas, you're learning to speak the language of banks. Keep going. You're already thinking like a future SBI PO. Shh. Now that we've completed question 1, send me question 2 and I'll break it down in the same way with emojis, examples, formulas, and motivation. Perfect. Let's now break down question 2 from your MBA Semester 2 Financial Management Module 2, Time Value of Money, with full emojis, simple words, formulas, and awesome examples. 2. Explain the future value of single cash flow and future value of annuity series of equal cash flows. What does this heading mean? Future value, FV, what your money will become in the future if you invest it today. A single cash flow means one-time investment. Annuity was series of equal payments made every year month, e.g. SIP, FD, with monthly deposits, etc. Hatcher A, future value of single cash flow. Definition: the amount a single sum of money will grow to in the future with interest added. Formula: FV equals PV times 1 plus RN, where FV equals future value, PV equals present value, amount invested today. R equals rate of interest per period. N NAGI equals number of periods, years, months. Short example. Suppose you invest $10,000 today at 10% interest for 2 years. FV equals 10,000 times plus 0.102 equals 10,000 times 1.21 equals 12,100. So your money becomes 12,100 in 2 years. And real-life banking example. If a customer puts $50,000 in a fixed deposit for 5 years at 8%, as a bank officer, you'll use this formula to tell them what they'll get at maturity. B. Future value of annuity series of equal cash flows. Definition. Future value of annuity means the total value of equal periodic payments made over time, compounded with interest. FV equals PMT times 1 plus RN minus 1, where minus PMT equals equal periodic payment, R equals rate of interest per period, N equals number of periods. Example. You deposit $2,000 every year in a savings plan that earns 10% interest for 3 years. FV equals 2,000 to 1 plus 0.103 minus 1.10, right, equals 2,000. Time for 1.3331 minus 1, 0.10, right, equals 2,000 times 3.31, 6,060. So in 3 years, your investment becomes 6,620. Real-life banking example. Imagine a customer invests $5,000 a month in a recurring deposit. As a bank officer, you'll calculate total future value using this annuity formula to tell them how much they'll get after maturity. Key points to remember. Single cash flow equals one-time investment. Annuity equals regular investments, monthly, yearly. Both help us understand how money grows. Used in FDs, SIPs, insurance, loan planning, retirement plans, helps bankers give accurate maturity values to customers. Difference table, single cash flow versus annuity. Feature, single cash flow, annuity. Number of payments, one time, multiple, equal. Formula, FV equal PV, 1 plus R it ends. FV equal PMT. Use case, FD, one-time invest. RD, one-time invest, monthly deposits. How it helps in bank PO, interview, or real work. As a future probationary officer, this concept is damn important. To explain future returns to customers, suggest RDs, FDs, SIPs based on needs. In SBI PO interviews or GDs, you might get questions like, how will you calculate maturity value for recurring deposits? So this chapter gives you a solid foundation to handle such tasks. Future value. What your money becomes in future. Single cash flow equals one-time investment growing over time. Annuity, series of regular investments growing together. Used in banking, finance, investments, retirement plans. Important for SBI PO interviews, exams, and real banking jobs. Short motivation to keep you moving forward. Every formula you learn today adds power to your tomorrow. The future is waiting for a bank officer like you, so don't stop now. Ready for the next concept? Just send me. 3. Explain the concept of EMI with its calculation. Discuss the methods of calculating EMI with example. Let's keep rocking the textbook together. Awesome! Now we'll learn a very important concept for banking, interviews, and real life. #3. Explain the concept of EMI with its calculation. Discuss the methods of calculating EMI with example. What does this heading mean? EMI equals equated monthly installment. This is the fixed amount you pay every month to repay a loan. EMI includes both principal, loan amount, plus interest. A. What is EMI? Definition simplified. EMI is the fixed monthly amount paid by a borrower to a lender, bank, to repay a loan over a specific period of time. It includes both interest and principal. You take a home loan of $5,000 for 5 years at 10% interest. Instead of paying all at once, you pay a fixed monthly EMI. That's easy for you and safe for the bank. Bank officer role. As a probationary officer, PO, you'll often suggest loans and calculate EMIs for customers using formulas or software. So this is a super practical skill. EMI formula. EMI equals frac P times R times 1 plus RN, 1 plus R squared N minus 1, where P equals principal loan amount, R equals monthly interest rate, annual rate by 12,100, N equals number of monthly installments, loan term in months. Step-by-step example. Suppose you take a loan of 1,000 cents. Time equals 2 years, i.e. 24 months. Interest rate equals 12% per year. Monthly rate R equals 1200 equals 0.001%. Now plug into formula. EMI equals frac 1000 times 0.01 times 1 plus 0.01 to 24, 1 plus 0.01, 24 minus 1. EMI equals frac 1 times 0.01 times 1.26824. 1.2624 minus 1 equal frac 11268.24 equals 4,727.50. So, your monthly EMI equals 4,727.50 units. See methods of EM calculation. 1. Flat rate method. Interest is calculated on the full principal for the whole loan period. Same interest every month. Formula, EMI equals frac principal's total interest, number of months. Example, our loan equals 1,000, rate equals 12%, time equals 2 years, total interest equals 100,000 times 12% times 2 equals 24,000. EMI is 1,000 plus 24,000, bar 24 is 5,166.67. Simple to calculate, not fair to borrower, more interest. 2. Reducing balance method. Interest is charged only on the outstanding loan balance. EMI includes more interest in earlier months and more principal in later months. More fair and used in banks today. Slightly complex formula, already shown above. Bank use case, why this matters. As a bank PO or manager, you'll approve loans like home loan, car loan, education loan. Explain EMI methods to customers. Help them compare between flat rate and reducing rate. Take part in loan marketing, designing repayment plans. This topic will help you in interviews, internship roles, and daily work in banking and finance. Key points to remember. EMI equals fixed monthly payment for loans. Includes both interest plus principal. 2 methods, flat rate versus reducing balance. Reducing balance is widely used by banks. EMI formula is super useful in banking career. Summary. EMI helps repay loans easily in monthly parts. 2 main types, same interest every month, and reducing balance. Interest reduces as principal reduces. Very useful in banking, finance, and loan management. Short motivation to keep you going. One formula today can open 1,000 doors tomorrow. Every topic you master makes you more confident for the bank PO role. Let's keep pushing. Ready for the next concept? Great! Let's dive into another super useful and scoring concept in finance and banking. You'll find this very handy, not just in exams, but also during bank PO interviews, real-world banking jobs, and loan investment evaluations. #4, present value of perpetuity and present value of growing perpetuity. What does this heading mean? Present value, PV, current equals today's worth of future money. Perpetuity equals a series of equal payments forever. Growing perpetuity, a series of payments that increase at a constant rate forever. We are going to learn how to find today's value of cash flows that come forever. This is useful in valuing stocks, government bonds, pension plans, etc. Current, etc. A. Present value of perpetuity. Definition, simple version. Perpetuity is a series of equal cash flows that continue forever, and the present value is the current worth of those infinite payments. Formula, PV equals frac C, R, where, and it's PV equals present value, C equals constant cash flow per period, R equals interest rate or discount rate. Simple example. Suppose a bank promises to pay you $1,000 every year forever, and the interest rate is 10%. PV equals frac 1,000, 0.10 equals 10,000. So the value of these forever payments today is 10,000. Banking relevance. Banks and insurance companies use perpetuity concept to value pension plans, life annuities, or endowment policies that continue forever. As a bank officer, if someone asks you about an investment that pays fixed returns for life, this formula is super useful. B, present value of growing perpetuity. Definition, simplified. A growing perpetuity is a stream of cash flows that increase at a constant rate forever, and the present value is the value of those increasing payments today. Formula, PV equals frac C, R minus G, where C equals cash flow in the first year, R equals discount rate, interest rate. G equals growth rate of cash flow. Important, RG, otherwise math won't work. Example, you get 500 next year and it increases by 5% every year forever. Discount rate is 10%. PV equals from 500 and that's like 0.1005 equals 5.05 equals 10,000. Even though the amount grows every year, its value today is 10,000. C. Key differences table. Feature. Perpetuity, growing perpetuity, today, it's 10,000. Cash flow, same every period. Increases every period. Formula, PV equals C by R, PV equals C by R minus G. Use bonds, pensions, stocks, dividends. Banking and real-life connection. As a bank PO or manager, you'll evaluate pension products that pay lifelong fixed returns. Perpetuity. Value growing dividend stocks or lifetime insurance payouts. Growing perpetuity. Understand how long-term fixed income or investment plans are valued. Use these formulas in loan planning, investment advice, and even stock research. E. Key points to remember. Perpetuity. Equal cash flows forever. PV equals C by R. Growing perpetuity. Increasing cash flows forever. PV equals C by RG. Used for valuation of income streams that never end. Helps in financial planning, investment banking, and asset valuation. Perpetuity gives fixed returns forever, e.g. 1,000 per year forever. Growing perpetuity gives increasing returns forever, e.g. 500, 525, 551.25. Present value helps us know what that future income is worth today. These are crucial tools in banking, finance, and investment decision-making. Short motivation for you. Every formula unit is a financial superpower. You're not just preparing for exams, you're building the mindset of a future bank manager. Ready for the next topic? Please send next question from your syllabus or textbook. Let's keep the momentum going. You're doing great.